Hello everyone. Let us move to the next lesson, that is coordination compounds. Now, what are coordination compounds? You might have heard in last year about coordination compounds. It was not there, but just you might have heard that name, coordination compounds. These coordination compounds are nothing but compounds in which metal atom or ion bonded to neutral molecule or anion through covalent bond or coordination bond. Okay, covalent bond. Okay, it's called a coordination compound or coordination compounds. Compounds in which metal atom or ion, that is a central metal atom or ion, is bonded to neutral molecule or anions are called ligands. Okay, through coordinate covalent bond or just a coordinate bond or coordination bond are called coordination compounds. Okay, and these coordination compounds are find application in the field of electroplating and textile industry as well as in the dyeing industry. And you can observe this coordination compound naturally in hemoglobin or chlorophyll and as well as in vitamin B12. These coordination compounds are main constituents. Okay, in hemoglobin, chlorophyll or in vitamin B12. Heme group coordination compound site, heme group you might have learnt, or in chlorophyll magnesium, Mg2 plus ion, that is acts as central atom, etc. Central metal atom, or ion. And in cobalt also acts as a central metal atom in vitamins. Okay, these are very, very important coordination compounds. Let us move to the next topic, coordination compounds and double salts and coordination compounds. Double salts and coordination compounds. See, these double salts and coordination compounds are very, very important. They may ask for 2 marks there in your board exam. Okay, what is the difference between coordination compounds and double salts? These coordination compounds or double salts are formed by mixing of 2 salts. If we mix 2 salts, then it results in the formation of another salt in stoichiometric ratio. The mixing of 2 salts must be in a stoichiometric ratio. The resulted compound are of 2 types. One is double salt and the one is coordination compounds. Hope it is clear for you. Whenever you mix 2 simple salts in stoichiometric ratio, it results in the formation of new crystalline compounds. Okay, and these are of 2 types are called double salts and one more is as a coordination compound. Okay, you already came to know what are coordination compounds. when solutions of two or more simple salts are mixed in stoichiometric ratio and then concentrated and cooled. When we mix two or more simple salts, results in the formation of new crystalline compounds. These formed new crystalline compounds are of two types. One is called double salt, another one is called coordination compounds. Let us see what are double salts. Yeah, as I said, double salts are also formed by the mixing of solution of two simple salts in a certain stoichiometric ratio. Concentrated and cooled will result in the formation of one new compound. Okay, and on dissolution, if this resulted compound results in the formation of ions or two or more simple ions, then are called double salts. Hope it is clear for you. You will mix two or more simple salts. It results in the formation of new compound, new salt, crystalline salt. If that crystalline salt on ionization results in the formation of a simple ions, two or more simple ions, then are called double salts. Okay. A salt is formed by the combination. Salt is formed. That is the common definition. Formed by the combination of two or more simple salts. More simple salts, and which ionizes to give two or more simple ions. Okay, two or more simple ions are called double salt. That is two or more type of simple ions. Okay, different. If it is two types or three types of simple ions, then are called double salts. Example is carnallite. Six molecule of water, ore of magnesium, carnallite, and which on ionization it results in the formation of potassium ion, magnesium ion, and Cl minus ion. 3 types of ions. Clear? How it is formed? By mixing of simple salts. Potassium chloride salt and magnesium chloride salt result in the formation of carnallite. Which on ionization, which results in the formation of K plus, Mg2 plus and Cl minus. And this solution, in solution, it will give in a solution, it will ionizes as K plus, Mg2 plus, Cl minus ions in solution. And this solution will test for, you know, right, already you tested how to test inorganic salt. That solution will test for potassium, magnesium as well as chloride ion. Hence we can define this carnallite as a double salt. One more example is potash alum. That is K2 SO4 Al2 SO4 thrice. Why? SO4 2 minus Al 3 plus Al2 SO4 thrice plus 24 molecules of water. Okay. What it represents, it's a hydrated compound. It doesn't mean that it is in water. Okay, it's hydrated compound. It's crystallized as this. Okay, in its crystal, 24 molecules of water is trapped. Okay, and it is called potash alum. And it ionizes as K plus, Al3 plus and SO4 2 minus. And the solution will test for potassium, aluminum and sulfate ion. Hence is called double salt. Hope it is clear for you now. A new compound is formed by mixing of 2 or more simple salts in stoichiometric ratio and which on ionization to give simple ions, right, are called double salts. Next is coordination compounds. Yeah, as I said, coordination compounds are nothing but metal atom or ion is bonded to neutral molecule or ion, that is an anion, through coordination bond or coordinate covalent bond. Right, are called coordination compound. I am not going to write a definition again. Hope it is clear for you. First type is a double salt. Double salt we discussed, and second one is coordination compound. Okay. See, as I said, we mix together 2 salt, result in the new salt which ionizes to give simple ions. Coordination compounds are central atom is bonded to number of ligands through coordination bond. And which on ionization? When we ionize this coordination compound, it may or may not be ionized. First thing, it may or may not be ionized, and whenever ionization takes place, it results in the formation of 2 types of ions. One is complex ion, another one is a simple ion. Okay, on ionization, it may or may not ionize, but on ionization it results in the formation of two types of ions. One is called complex ion. Another one is called simple ion. Complex ion and simple ion. For example, CuNH3, CuNH3 4 times, it's in coordination sphere, and SO4. Okay. Now it ionizes as CuNH3 4 times and 2 plus SO4 2 minus. Okay. One is called complex ion and other one is called simple ion. Complex ion and simple ion. Okay. There are two types, complex ion and simple ion. Okay. And it need not be dissolved in water always. It may or may not ionize in water. Whenever it ionizes in water, whenever it dissolves in water, it may or may not be ionized. If it is ionized, it results in the formation of two ions, complex ion, simple ion. That's all. Okay, other examples. K2 PTF6. Okay. And ionizes as 2K plus PTF6 minus 2 minus. Okay, 2K plus and PTF6 2 minus. Again CONH3 6 times. I will write there. These are examples for coordination compounds. CONH3 6 and CrCN6. Okay, don't write this 6 like this. You have to put a bracket and have to write. This 6 is for carbon as well as for nitrogen, right? And gives CONH3 6 3 plus CrCN6 3 minus. Okay, square bracket. This is called coordination sphere. You have to write inside the coordination sphere. Okay. Next is a difference between double salt and coordination compound or complex salt. They may ask double salt and coordination compound or double salt and complex salt. Okay, don't get confused. It's clear, right? Difference between double salt and complex salt or coordination compound. Complex salt. First one is double salt. Next is a coordination compound or complex salt. Coordination compound. The same. And first difference is double salts exist only in solid state. They exist only in solid state. That is, in aqueous media, it will dissolve. It ionizes into its constituent ions. Therefore, double salts are present only in its solid state. If you dissolve in water, or if you take this double salt in water, it ionizes and results in the formation of constituent ions. Hence, it exists only in a solid state, but coordination compounds exist solid state as well as in a liquid state. Sometimes it ionizes, it may ionizes or may not be ionizes. First one, it exists, it may exist in solid state as well as liquid state. Liquid state may exist in a solid state as well as in liquid state, because these coordination compounds will not dissociate in what it may dissociate or may not be dissociate, or it will not, complete dissociation will not takes place. Why? Since in aqueous solution, it will not dissociate. It will not dissociate. Okay. Hence, we can observe these complex salts in solid state as well as in a liquid state. That is, in water also you can find this complex salt as well as in a solid, or you can observe this compounds. Second one is these double salts are ionic compounds. Ionic compounds, and we cannot observe coordination bonds in case of a double bond. But complex salts may or may not be ionic, and we can observe coordination bond. Okay, there must be coordination bond in a coordination compounds. Do not contain any coordination bond. I'll explain what is coordination bond. Not contain any coordination bond. These are may or may not be. May or may not be ionic. May or may not be ionic. They contain, there must be a coordination bond. They contain coordination bond. And third difference is this double salt on dissociation or on ionization results in the formation of its constituent ions. And these constituent ions, its nature is different, entirely different to that of a double salt. It is the properties of constituent ions. Constituent ions. What are constituents? It ionizes as K plus, Cl minus, etc. These are constituent ions. Its property is same as that of a double salt. The properties of constituent ion or ions is same as that of double salt. Or properties of double salts is same as that of constituents, or properties of constituents properties of a double salt is same as that of a constituent ions. Ions is one and the same. But here, third one, properties of complex salts are different to that of constituents. Constituent ions in the sense complex ion and a simple ion. The properties are different. And metal ion exists in their normal valency here. Fourth one, metal ion exist in their normal valency, but in coordination compounds, metal ions surrounded by the ions or neutral molecules exhibits beyond their normal valency. Is important. Here, metal ion surrounded by neutral molecules or ions exhibits valency beyond their normal valency. Okay, I'll explain you later. Okay, these are the difference between double salt and complex salt. And I have observed few are writing difference like first difference, it exists only in solid state, and other difference is that is right, but there is no relationship between those two. They'll write exist only in solid state, properties of complex ions are different to that of constituent ions. So that is first difference. It should not be. Okay, you have to take one property and you must differentiate in that property. That's all. Thank you.